Okay, so here we are. Growth and decay, the same functions that we used yesterday for graphing exponential functions, we are going to use because there is an exponent in there as a variable. So this is, I'm going to give you three equations depending on what it is you're finding. Okay, so the first one is exponential growth. In exponential growth, it's kind of light because it is a photocopy, but you should be able to see it. Otherwise, you can always go back to your book and look it up too. So in this equation, y is the final amount that they're asking you for. They'll say, what is the amount after blank and blank time? Okay, a is the initial amount, so where something started. The 1 plus r is your rate of change. So for example, if it's growing by a rate of, right down here, 2.85%, you're gonna write that, but you're gonna write it as a decimal. So changing percents to decimals is something you're gonna have to do on a regular basis, okay? And then the last one, you're raising that to a power of t, whichever is time. So depending on the equation, your time might be days, your time might be years, your time might, whatever it is, okay? Your time might be increments of 20 minutes. You remember how we did that one? Okay, so here's the first example. We are going to use this function. So make sure you have your calculator ready. Write an equation to represent the population of Idaho since 1990. In 1990, the population of Idaho was 1,006,749. Since then, that number has increased an average of 2.85% per year. So time here is years, okay? So write an equation. So y equals our initial amount, which was 1,006,749. Now in our parentheses is going to be 1 plus our rate of change as a decimal. So 2.85% becomes 0.0285. I almost didn't leave enough room there. And then times t. And t is how many years since 1990?
But
yes.
It doesn't like give us t?
It will. The first one just says write an equation. Okay. So we're writing the equation.
So
now, that's the formula. Okay. So now for B, they ask us to now use that equation to find the population of Idaho in 2000. Well, first of all, 2000 is how many years after 1990? 10. So T is going to be 10. So here's where you get to plug it in. Now, if I were you, I'd simplify this out a little bit. And what I mean by that is I would actually add the 1 plus 0.0285, excuse me. So 1.0285, and that is going to be raised to the 10th power because years is 10. So now when you do this on your calculator, you can probably type it in 6,749 times 1.0285 raised to the 10th power. But I'm not going to lie, I tend to do my power first, 1.0285. And remember, we don't have a button that just takes it to the 10th power, so we have to use that caret button right here. It's a caret. It's like the arrow button.
Oh, yeah.
Yeah. So to the 10th power, and whether, I'm going to hit equals, not that you have to, and then times 1,006,749. Now, 9 times out of 10 when you do this, folks, you're going to get a decimal. It's going to be ugly. But what are we talking about? We're talking about the population of a state. So when we round it, it makes sense that we round it to the nearest whole number because we're talking about people, okay? And I'm going to even write about so that you know it is an approximation. So 1,333,411 people in 2000. How was that?
Yeah, are you 100% correct on that?
I am. You may have just missed a decimal or something. So, our calculator is great, but you have to make sure you're being careful about what you're plugging into it. So take your time, because there's a lot of keystrokes. Do you want to do another example like that?
Yeah.
Just like that?
Can we just write the equation?
What's that?
Just practice writing the equation and just start solving. It's easy. Solving's fine. We just have to-
Actually, we will do some more examples. Can I just go on to the next one? We will do some more examples. So that is just exponential growth per year. So how many of you have heard of compound interest? Right? How many of you either have a credit card or have access to a credit card or know your parents have a credit card? Right? All y'all should have your hand up, right? So our credit cards compound interest. What that means is it's not just one time per year. Some credit cards, it might even be more than once a month where they compound interest. It's not a very good credit card. Most of the time it's once a month, but sometimes it's even more than that. So this is the equation for compound interest. Okay, whether it's interest you are paying in on a credit card or interest you are getting from the bank by money you've invested. All right, so lots of variables in here, and this is a little bit more elaborate. So A is just the amount you're looking for. P is the principal. That means how much money you started with. Okay, how much money was invested or borrowed at the beginning. Then the 1 plus, check this out, we got a fraction inside of our parentheses. The R, again, is your interest rate. If they give it to you as a percent, you write it as a decimal. And then divided by N, where N is the number of times the interest is compounded in each year. So if they say monthly, N is going to be 12. If they say it's compounded 24 times a year, N would be 24. All right, so you have to get a lot of information. And then we raise that to an exponent, and the exponent is actually two variables multiplied together. The number of times you compound it, and then how many years. Okay, so while it's more complex, you'll be okay. All right, just follow it. So let's look at this. Anna's investing money. Actually, Anna's parents are investing money. Come on, Anna, get it together. All right, they plan to invest $4,000 in an account, for her with an interest rate of 9% compounded monthly for 5 years. So we've got a bunch of stuff here. Right here, 4,000 is our principal, right? 5 years, that's our T. That's how many years. If it's compounded monthly, then N is 12 times in a month, or 12 times in a year that it's compounded. And then our rate is going to be 0.09. So let's look at that equation. Follow it along. We've got A equals $4,000, parentheses, 1 plus, here's our fraction, our rate, 0.09 over 12 times, parentheses, to the 12 times 5 power.
So you're finding A.
We are going to find A. We're going to find, after 5 years, how much money does she have in that account? It better be more, right? Because she's making interest. Yes.
So for N, if it's getting compounded monthly for 5 years, shouldn't it be 12 times 5? Is N?
Right, but N is just how many times each year it's compounded.
Oh, each year.
So if they say monthly, it's 12. Okay? The 5 is why you take it times 5 out here.
Yeah.
So now let's simplify that. Obviously in here, I'm going to have to take 0.09 divided by 12. Right? So let's do that first. 0.09 divided by 12. And you get like 0.0075. I'm going to go ahead and add that 1 to it right away. So it's 1.0075. The 4,000 is still there. And then I'm going to go ahead and multiply 12 times 5 in my exponent, which is 60. So This would be hideous if you had to do this by hand. It would take you like months. All right, so 1.0075 to the 60th power. And then we multiply that by the 4,000. Now remember, this is money. So we're going to round to 2 decimal places because we're talking dollars and cents. So it is approximately, and that's why I'm going to make my squiggly lines here. So approximately $6,262.72. Is that where you guys ended up?
No. Yes. $4,125.
Oh, biscuits. You screwed up somewhere.
Obviously. I got that.
But they're right there, Keaton. Did you say 700 and some thousand?
Yeah.
Okay, so maybe that's a hint. that I wish I could invest in that one, but that's probably not a realistic answer, right? So she did make quite a bit of money, right? Over $2,000 that grew by, right? That's not bad. Okay? All right, let's do the back. One more. This one, another type of equation. We're talking about decay. You maybe have even done these types of equations. If you haven't yet, you may see it in earth science. When they start talking about how much something decays and how long it takes, they specifically use the word half-life quite a bit, meaning how long it takes it to cut in half, right? So exponential decay, this is what happens when the original amount decreases. So if something is going down by a percentage over a period of time. So notice it's very similar to exponential growth. The only difference is you're subtracting the rate instead of adding the rate. Because it's decaying, exactly. So otherwise it's the same thing. Here we go, prairie dogs. In 1995, the prairie dog population of a nature preserve was 1,500. Since then, the population has been decreasing by about 4.5% each year. Write an equation to represent the prairie dog population since 1995. Then estimate the prairie dog population in 2005. So our equation is going to be the initial amount, 1,500, times 1 minus 4.5%, so 0.045 parentheses, and I'm just going to leave it T up there. So now we have to take 1 minus 0.045. Just because they asked me to write an equation to represent the situation first. So did anybody take 1 minus 0.055? Full 5?
0.955.
So there is our equation that we are going to use. Then, so write an equation. Check. Done. Now estimate the prairie dog population in 2005. Well, what is T in 2005? 10 again. So get out your magic box.
955.
What is it? 955?
No. 95. You have 995.
Oh, I do. Thank you. Good check. Good check. Thank you. So I have
It's like 946.
947.
Oh, yeah.
right. And so we're rounding because we're talking about prairie dogs, so kind of have to round to the nearest whole because we don't have half prairie dogs sitting out there. We might have half prairie dogs sitting out there, but they're not alive, so we can't count them. Okay, so 947 when we round up, right? So about 947 prairie dogs.
Instead of writing about, can you just
Do this?
Yeah, can you just put that?
That would be fine. Okay? How are we doing? So here's another, well, I won't say. You have to tell me. A fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. Write an equation to represent the loss of air.
So, yeah, this is DK.
So it is DK.
So Y equals 4,500.
Initial value, 1 minus 0.066.
Memorize these equations for the test.
Or are you going to have them like written up there?
So 4,500, nope. And it will be 0.934, right? So there's our equation. Now for B, after 7 days, what's the amount? So now we just take that equation and we plug 7 in for T. So 4,500. And remember, this is amount of air, so we can probably go a couple decimal places. So again, I'm going to do approximately. Cubic inches, right?
How many decimals is
You know, I went 1. It's 2 would work too. I didn't specifically say, so 1 or 2 is fine.
And you got cubic inches because it originally contained 4,500.
Right. Mm-hmm. We're going to do a couple more examples, but I got to give you a sheet for that. Any questions? Yeah, sure.